I am Sait Sarper Özaslan, and this is my EE-102 turn project password system. In this project, I use buses 3 FPGA, a bunch of jumper cables to connect the infrared sensors, and in the buses 3, I use the 7-segment display, the buttons, and finally 2 switches for enable. Actually, my project is a password system. We set up a 8-bit password in the shift register in the first phase, and in the second phase, we use the infrared sensors to try the password, and if the password is correct, it will display C. If it's false, it will display F in the 7-segment display. For the password system, I use the state machine over here. This is a Moore machine. Essentially, we start from state S0. If you press the right sensor, if you show your hand to the right sensor, it will go to the state S1. And if you keep on going like this, you will finally reach state S4, which sends the signal correct equals 1, and that displays correct CCC on the 7-segment display. But for instance, if you make a mistake in state S1, you will go to state E2, and it doesn't matter which sensor you use. It will keep going in the error state, and it will finally reach the state error 4, which will send the signal false equals 1. From error 4 or S4, if you press the right button, you will go to state S1, and you can keep trying to find the right password, but if you make a mistake, you will go to state error 1 again from E4 or from S4. I will show how my project works. In the first state, as I said before, we set up an 8-bit password in the shift register, and for that, the enable and the leftmost switch must be on. If you press the leftmost button, it will send the signal 2. If you press the middle button, it will send the signal 1, and if you press the right button, it will send the signal 0. For instance, our password right now is 0210. Let's add another to this and make our password 2102. In the second state, we need to use the sensors to enter the password, and we'll see whether it's correct or not. Our password was 2102, so let's try. The rightmost sensor gives the value 2. Then we go to the middle one, which gives the value 1. Then we go to the leftmost one, which gives the value 0. We also need to press another button to see whether our password is correct or not, which was 2. And if you press right, it will display correct. But for instance, we sent the wrong signal at some point, and I will display that as well now. Let's say our password is 2111, and I need to press one more because I've only pressed 3 times so far. And if I press this, it will display false. Since if you want to reset the password or change the password, you can keep pressing on the buttons as this is a shift register, or you can press the topmost button to reset the password and set up a new password. Same goes for trying the password. If you realize you have made a mistake, for instance, you can press the button in the bottom, and it will reset the password, and you can try again. Finally, I will briefly explain the coding part of it. Essentially, I have one main module, and under it, as I explained, 2 states where one of them is register and one of them is trying to lock state. I have reg top and lock top. Under these states, I have clock divider and clock pulse. Clock pulse is essentially sends one signal if I press the button once. Even if I keep pressing it on, it will only send the signal one time. And in both states, as I register the password and show it on the 7-segment, I have shift register top and 7-segment code. And finally, when I'm trying to lock system, as I explained the Moore machine over here before, I have the lock state code. Thank you for listening to me. See you on another project.